Hello everyone. So in this lecture we are going to go over graphical presentation of data. So data can be visualized by creating graphs and that is sometimes more informative or um, quicker interpretation of data can be achieved through this graphical presentation. And you can use different kinds of graph depending on the nature of data. So the data might be categorical, meaning that a variable in a data set has got multiple categories. So as an example, blood group variable could have multiple categories like A, B, O, AB. And then another type of variable in a data set could be quantitative data, or it can also be called as continuous variable. And the example of that would be some quantity. Example, midterm scores of students. So we use different kind of data, or we use different kind of graphs for representing categorical variables in a data set and quantitative variables. So for categorical variables, we can either use pie chart or bar graphs. Right? So pie chart is something like simple as pie. So you create a pie and then you can represent each portion of that pie with the category of each of these variables. Now, the limitation of pie chart is that you need to have all of these together constituting to one categorical variable. So it can be created only for one categorical variable. But most statisticians use these bar graphs for categorical variables. So that can be represented on an axis of X and Y and with the different bars representing each of these categories. So in this case, as an example, these are the number of peoples or patients having blood group A, B, O, AB. And remember, on the Y axis, you always have some measure of frequency. It could be normal frequency counts, relative frequency, percentage, and so on. So the reason the bar graphs are important here or preferred by statistician is because it's easy to compare different bars in one data set or one graph. Other reason is that you can also represent the preference of data. So as an example, if you have a question or variable asking for do you like coffee, then do you like tea and milk. So these are actually three different questions, but you can represent all of these three questions in one data set. So possible answers for these questions, if I want to answer, maybe I could say that yes, I do like coffee, maybe I don't like tea, but I also like yes. So what it tells is that there is some overlap in response. So I do have like two different kind of responses or liking. So I might be liking coffee as well as milk. So I will be in this as well as this particular graph. So that can be represented using this bar graphs. So that is the advantage of this bar graphs. On the other hand, if you look at this quantitative data, or we call it as numerical data, or continuous variable, or continuous data. So for those things, we traditionally use three different kinds of graphs. One is stemplot, another is dot plot, and the last one, which is more popular, is histogram. Now for the stem plot, I'm going to briefly describe it here. So stem plot, you just have to divide the data set into two different components. Those are called as stem, represented on the left side of this vertical line, and then leaf or leaves based on how many number of data points you have. So let's say you have a data like this 9, 9, 99, 10. Right? So first thing in any kind of graphical representation of data is sort the data set in ascending order, preferably. So in this case, I would sort it as 9, 9, 10, and 99. And then I will go and represent this data. So in the stem plot, you need to remember the stem is everything but the rightmost digit. So in this case, the number 9, the rightmost digit is 9. So that is nothing but the part of your leaf. But what is the stem? Everything but the rightmost. So in this case, you can see that this number is 09, right? So the stem here becomes 0 and the leaf becomes 9. So this was the first data point. If you look at the second data point, that is also 9, but you just don't consider that we already mentioned 9 because it is a different data point. So you write the 9 again with the stem as 0. For the number 10, your rightmost digit is 0 and everything but the rightmost is 1. So the 1 here becomes your stem. And since it's the 10th data point, you need to create or write here 0. That doesn't mean that there is no data set. That means there is a 10 as a data point. On the other hand, if you don't have like this 20th stem, so you don't have after 10, you directly have the data point as 99. So you don't have data points for 20th digits, so you're going to keep it blank by writing the stem 2, 3, 4, 5, 6, 7, 8, and you're going to keep it blank. Remember that if you write here 0, that means that particular data point is there. So 20th, 30th, 40th, but we don't have 20th, 30th or other data points here. We directly have 99. So again, everything but the rightmost is going to be in your stem. So 9 is going to be in stem and the rightmost is going to be leaf. So this is briefly. For more information, please check out the chapter 1 from this book, Practice of Statistics. Now the second type of graphical representation which we use for quantitative data is a dot plot. So dot plot is nothing but presenting a data in the form of dots on an axis. So let's just, for simplicity, look at this data. 9, 9, 10, 99. And remember, we already sorted it according to ascending order. So based on that, you just create a scale of data and then represent each data as point. So in this case, if I want to represent this data with the scale of 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, to 70, 70, 80, 90, and 100. Notice that I have created this cell by looking at the data first. I know that my minimum value here is 9 and maximum value here is 99. And overall, I also looked at the distribution of the numbers within the data. So good practice is you always start the class from fives, class of fives, and class, if that doesn't work or if the graph doesn't look good, go for tens and so on. I already noticed that if I create a class of fives, I will have like more than required spreaded data, and that also can lead to loss of information. So I decided here to go with class of tens, that is 0 to 10 and so on. But this is an iterative process, so practice on this, and then you should be able to get the desired graph. So in this dot plot, if I want to represent this data in the dot plot, I'm going to represent this 9 somewhere here, closer to 10, as one dot. Now another data point is 9, so what do we do about this? So you just stack them up on one on top of other. Then third data point is 10, so I would create dot here and then directly 99. Now this data is like only for explanatory purpose. You already know that it doesn't make a lot of sense here, but this is just to give you some start and guidance to create the dot plot. Now looking at the histogram. Histogram is nothing but, you can think about it as continuation of dot plot. And I'm going to go over how to create the histogram with one specific example. But before that, I would like to conclude this session by stating one more point. That is, stem plots and dot plots are most commonly used for smaller data, and the histogram is used for larger data. Right? All right, so that is all about the introduction to graphical presentation, and this is the decision tree that you can use in order to decide what graphical presentation is more appropriate for the kind of data you are using.